it's gonna assign that as, location. If I don't give it a location, it's gonna be 0. If it's 0,
Which is there.
is there. And so we probably don't want that. So we go auto sample location 1. Okay. And then we're gonna go standard, STD 1. And the concentration is 5. Why do you not? Why does it not just automatically doing it? It will for the flaming. It just goes right down the line. Okay. Position 3. And if we save, okay, now if you want to go check method, it'll tell us what's wrong. Oh, guess what? I didn't tell it what the concentration was.
You told it what the country, you didn't tell what the volume was.
No, please. Auto sample volume, total rejection would be the same for standard samples, but that's only if I, oh, yes, I do. I have to go 20. Tell it where go over here. What injection volumes? What's the calibration? Oh. That's all right. Okay. Video location 1. Told it to, for samples, I'm going to shoot 20. I'm not going to put. Then you go here, check method, it says both auto sample location and a volume must be defined for each. Because I haven't hit anything. Standard 1, standard 2, auto sample. I don't have it deleted. I don't see where the problem is. I don't want to calculate problems. Answer. And it's telling me both an auto sample location and a volume must be defined on the calibration page for each.
Oh,
Yeah, there we go. I left the blank. There you go. I'm like, why did I leave? I was at this, yeah. So we save this. Okay. So we come back into here and we say rebuild the list. That's what we've got. Okay. Or it's just for the sake, and then I would analyze all. And we run these just like that. Or I go to select location 1. Now what's it doing? Remember that?
yeah.
It's setting this. It's going to the max. It's going to the max temperature calibration of the probe. And then over here, it's telling me it's in this cool down. This is the status page. See what it's doing. It will come in and pick up the sample, and it will sit here. And when it does, it's doing the baseline offset correction. You remember what those are? It's just looking at the intensity of the lamp, because it has to project it forward. Right there's when it's doing it. You cannot have a mirror up there watching it put its injection in. If you want to watch it put the injection in, you're going to come over here right now. Alright. And it went in, we didn't bend anything, so A-okay. And then the next thing I want to do is I want to watch and make sure that it's flushing it. Okay. It's showing me it's up to 110 now. Step 1 5. This is the temperature limit. So I'm going to take my watch glass and watch. See the
Oh, yeah, you can
moisture?
see the
Yeah.
condensation.
Right. So we have a 2-step dry, because dry is very critical. And you know, we're only, if I'm 20 degrees too high, splatter it everywhere. If I'm 20 degrees too low, and it's all relative to your incoming voltage, it's not going to dry right. So we're on our way up to 130, and it's dry. So that's why we go 110, just above the boiling part. And then we want to make sure it's nice and dry before we go up, because graphite's porous. If it, now, when we pyrolytically coat it, it means that we're coating it with methane under a heat treatment. Okay? And what it's there for is to take the graphite, make it less permeable. So it sits on top of it, let it soak into it. Well, after you've got 100 or so firings on it and you're using acid, it actually soaks down into it. So if you don't dry it good, if you go from it's going to blow microscopic pieces of it out. This is char. Then we're going to do atomization. There's atomization. You see go up there. That was when that took over. And then clean out. So you hear the cooler come on? And it will get faster and lower depending on what the temperature it senses. And then we have a peak.
Now, is the temperature program preset into the
Yeah, we use the
UPP
default.
element and the
Yeah.
default function?
Now, if you go to recommended conditions, it tells you what they typically should be, 16, 50, and 25. But it's assuming that you're using the matrix modifier. And if you're not, you want to drop that this to, maybe about 1,000. You don't want to take the chance of losing it. One that I always remember, don't have much graphite furnaces anymore. But all environmental lamps used to use before ICP and ICP, mass spec became prevalent. So selenium is very volatile. At 400 degrees, you start losing it. You don't have enough modifier. Well, the default was at 1,000. And somebody would come and say, I have no numbers for selenium. Well, what about your arsenic and lead? Well, they're fine. Well, they didn't have numbers. Lower your char temperature and see if you get, I made it up right. I got no idea. I got some more. Kind of do. It tells you a little bit about it. Diluent. There's no special remarks on this. But it's chrome. You probably, if you were running 1,000 selenium or arsenic or something, you'd have more comments to it. Chrome is very easy. Like I said, the reason I check chrome is I don't want to see the negative. Because at 357, you're up into the greenish part of the spectrum. You can see the light.
So the auto sampler, station one, no matter how you have, station one is always there, or will it spin?
It will spin. Yeah, it will move whatever. I
Oh,
just
okay.
happened to choose, if I would've said 41.
It would have gone
It
to
would've
the
gone,
other.
yeah.
It would have.
Yeah. Yeah, it moves to it.
Okay.
Now, I was waiting for a cool down.
Yeah, it's gonna be one more time.
Yeah. But see, it got it all ready,
Yeah.
and it waited for it to hit the cool down. And then it did its baseline offset correction. And because well, it's not really doing baseline offset there. It's doing, it's looking at lamp intensity, making it stable. It's not an auto zero, because that's different. It's looking at the baseline. And BOC happens right here. And it looks at it again right before atomization and projects that out
Oh, the direction.
for 5 seconds, so that you know where the peak integration starts and stops at. All in all, I had never, like I said, I've never installed a furnace on it. It's a neat little setup.
I
you know,
knew that we could afford it, and that I knew that ICP would be expensive. So,
Well,
that's why
ICP's
they give
a lot more expensive to even operate.
I know,
too.
that's why. I knew the operation costs were daunting to me more than the
Yeah.
initial cost. And then, I can't remember what Agile wanted me to buy. They didn't even want me to buy three. They wanted me to buy some other, they have like an archer thermal, but it's not a replica, it's not a big.
You know, Agilent don't even make their own stuff.
Well, I knew that, that's the thing
When
that
it comes
gets
to,
me, is when it
atomic
comes to
absorption.
atomic spectroscopy, or just spectroscopy in general.
Yeah.
Agilent, is it like UV visiors, light rays, they like, actually, and that one's now on thermo, isn't it? The old HP 8450,
Yes.
those are now thermos.
Yeah.
And then, I know, well, we have a water gauge process system, but I know Agilent makes their own LC systems,
Right.
because that's what they do.
Yeah, GC and LC, that's what they're known for.
They don't have anything else they sell as first.
Yeah, well, they do, they want you to be in that market because they're, so
Well, because
they
they come down,
contract.
yeah.
Yeah, they contracted another company to build it for them. And I've heard the name of the company, but, that's probably A-okay. It's just, they're just not.
I told us.
Yeah, they're not a spectroscopy company.
Right.
I do have customers that have their mass spec, ICP mass spec,
Yeah.
and they got very low detection limits, but they can't run environmental samples. They can't run real world samples. So you ready to go back to flame, or do you want to leave it up to furnace?
Well, what else?
That's it.
Alright, so we've done everything.
Yeah.
Now, the percent RST is
Yeah, that
higher.
was crap.
Is that what we expect?
No.
Okay.
Yeah. I would.
What does that likely mean?
I would say, being that we had to move this furnace over to it,
Yeah.
I would say probably could line the furnace again. Because I had to move the auto sample. Remember how much we had to move the auto
Yeah.
sample relative to it?
Yeah.
So I would go to continuous graphics. And let's change the schedule. And then I would back to here. We have a long way before it has to affect the wind. It's fully got fell out. Good break, good. See that?
Oh, okay, there's one.
Yeah, it's just a silicon tube that goes in here. It's got a little clip. Now, I had like less than 1%. So there we go. Excuse me. And if you kinda wanna look, see, that should be about the middle.
Gotcha.
Okay, just,
More,
yeah. Look, that's where it really should be one way or the other, not about. And I ran it without background correction. Hit modify.
Oh, that's right. We need to back into the direction.
But we just run water, so I said, that much. And then you have to do all these adjustments without leaning on it, too. Now, since I've moved this, what do we have to do?
Now we have to realign the other side.
Absolutely.
So do I want to auto zero the graph or do I not care what
No,
the
it
graph
doesn't
says?
matter, 'cause I've got.
There we go. So line tip, right?
Yeah. And then you wanna tell it in the furnace.
So line the auto sample tip in the graphite
Yeah,
tube.
that's
Click
it.
next.
That's it.
So, yeah, click next.
Mirror.
Well, it tells you exactly what to do.
Now, the piece of, you have any piece of paper? Click on finish or whatever. Now, I will have to go to 15. Now, I actually ran mine with my lamp. And it actually needs stability with the lamp. Mine's brand new, but I don't. This is real world stuff we need to be changing anyway. actually, you know, I understand. Oh, yeah, yeah, sure. I actually forgot it was on.
Me too.